11.2 is covering arithmetic sequences and series. So the question here is, what is the difference between a with a subscript of 2 and a that is raised to the second power? Here's our notes that we need to write down. An equation to find any term, and then the arithmetic means. We also have some summation, so if we have to add up a sequence that is long, we can quickly do it with these formulas. And then we have a new notation. It's that Greek letter sigma, and sigma just means that we are adding up a list of function outputs. So let's take a look at this one first. Find the 20th term of the arithmetic sequence. So I've got up there the notes of this equation, because we're going to rely on this equation down here. So a sub n is the value of the term that we're looking for. We're looking for the 20th term. We don't know what that value is, so we put a sub n. A sub 1 is our first term, which was 3, plus the n is the term we're looking for. Well, we're looking for the 20th one, minus 1, and then d is our common difference. So what are we doing here? We are adding 7 each time. So our common difference is 7. Okay, if you would like to write it like this instead, you could do that as well. That's just a little bit of a different way that we're used to seeing it. I don't know why they put the d at the end, but that's the way that it's always written. But if you want to put that d up in front, that's okay. Okay, so you could either just type that into your calculator or calculate 20 minus 1 is 19. So 7 minus 19 is 133 plus 3 is 136. That's the value at the 20th term. So we could take the sequence and continue writing this out 20 terms like we did yesterday, or we can plug it into this formula and we'll quickly get the answer. Okay, how about this? Write an equation for the nth term. So this is just generally how we could quickly figure it out. So a sub n equals a sub 1, our first term, negative 8. Plus, I'm going to put the d out in front. I just like seeing it out here. That's more of what we're familiar with. So we've got, we're adding 2 each time. So 2 and minus 1. So that's the equation. Generally, we see it in slope-intercept form, though. So we would distribute this through negative 8 plus 2n minus 2. And so then if we combine like terms, we've got 2n minus 10. So that would be our equation to quickly find any term. Okay, how about this one? This time we're given the 6th term, we're given the difference, and we need to write an equation. So here we could use this to figure out what a sub 1 is, or we could just work it backwards. So let's plug it in and figure out what it is, what a sub 1 is. So we could put in negative 33 equals, don't know what a sub 1 is, plus, again I'm going to put the d out in front, negative 11, n, what's the term that we know? We know the 6th term, minus 1. Okay, if I calculate this part right here, that's going to be negative 11 times 5, plus negative 55, I can just put it like that, equals negative 33, and then I'd add 55 to both sides. So we get 22 equals a sub 1. Okay, that's one way that you could do it, and then plug it in here. So a sub n equals 22 plus negative 11 n minus 1. And then we can distribute that through. Let me show you a different way to find a sub 1. Okay, if I know that this is the 6th term, I can go 1, 2, 3, 4, 5, 6, and put negative 33. I know that I need to subtract 11 to continue on. So to work backwards, though, then you do the opposite. You add 11. So this is negative 22, negative 11, 0, 11, and 22. So if you'd rather do it that way, you can as well. The problem with this way is that if you are given the 20th term, that might get a little bit overwhelming. But the 6th term, we could definitely work our way back from that. Okay, we didn't actually finish this out because we should really distribute this 11 through. So coming over here, I've got a sub n equals 22 minus 11n plus 11. And then combine like terms, negative 11n plus 33. Find two arithmetic means between those. Find the arithmetic means. There's actually 3 of them there. Okay, so what we have to do is figure out what is the pattern that is going to continue this on so that we can get to 45 in 4 terms there. Okay, so the way that we could do this is take 45 minus 21. And you end up getting 24. So the distance overall that we need to cover is 24. And that needs to be divided up amongst how many changes there are. Now notice I didn't say how many spaces there are, but how many times did you have to add an amount on? That is 4 changes. So we have to divide that by 4, not by 3. And so we get 6. So that means each time we need to add 6. Now be careful when you do this. You need to go back and plug the numbers in and actually make sure it comes out with 45 in the right spot. So 21 plus 6 will give us 27. Add 6 again, you get 33. Add 6 again, you get 39. Just double check. If you add 6 again, you do get 45, and that means that we did it correct. Okay, how about if we need to sum up this series? Okay, couple ways that we could do it. We could write out this entire series. So the pattern is that we're adding 4 each time until we get up to 80. So that's going to be a long series that I need to write out. So what we could do is come up with one of these, let's switch those around, summation formulas. So we look at this and see, what do we know? We know our first term and we know our last term. Okay, so let's do this one then. So S of n, the sum of all of our numbers. Oh, but we don't know how many numbers there are. We don't know that part of it. That's why we're going to have to use this first formula. Oops. We're going to have to use this formula to figure out what n's going to be. So let's plug our stuff in. What is a sub n? Our last number is 80. A sub 1 is our first number, 8. Plus, again, I just like having that d in front, so I'm going to move that up. Our difference is 4 and minus 1. Okay, so distribute this 4 through. 8 plus 4n minus 4. Now be careful, you can't combine these two together and make 8 because order of operations says you have to multiply before you add. Alright, combine these two together and you get 4n plus 4 minus 4. 4n equals 76. 76 divided by 4 is 19. So that means I would have had to write out 19 numbers to be able to get the entire list and then add them all together. So that is our n value right here. So it is 19. A sub 1 is 8. A sub n is 80 over 2. Okay, now you can just plug that in. Let's do 8 plus 80 first and divide that by 2. That's 44. Times that by 19. And the sum of all of them is 836. All right, find the first 4 terms of the arithmetic sequence. So they're giving us the first one, they're giving us the last one, and they're telling us if we added them all up, they would add up to be 129. So we have to figure out, maybe we could just figure out how many terms there are. So let's use this one. S sub n, oh, we know what this S sub n is. We know that's 129. equals, I don't know how many n's there are, how many numbers there are, but I can tell you that there's 14 is our first term and 29 is our last term. Always divide by 2. Okay, let's do 14 plus 29, and then take that answer, divide by 2, get 21.5. So 129 equals 21.5 n. Divide both sides by 21.5. And I did something wrong. Let me retype that in. I get 6. So that means that I've got 6 numbers I need to write out. So I've got 14 is my first one. 1, 2, 3, 4, 5, 6. 29 is my last one. And now I can use my arithmetic means process that I did before. So I take 29 minus 14, and I've got a difference of 15. And I have to divide that up over 1, 2, 3, 4, 5 changes. So that means I have to add 3 each time. So 14 plus 3, 17, plus 3 again, 20, 23, 26, and 29. So it said, what are the first 4 terms? Those are the first 4 terms right there. And let's try this one. Evaluate this. Okay, so the way that we read this, is that we have this function 2k plus 1, and we have to insert numbers from 3 all the way up to 10. So what I would suggest doing is making a list. If I put 3 in there, I would get 2 times 3 plus 1. I would get 7. So I have to put 4 in there now. I have to go all the way up to 10. So 2 times 4 plus 1, because our function is 2 times the value plus 1. So 8, that's 9. 2 times 5 plus 1. 11. Now you'll start noticing a pattern. What's happening each time is that we're adding 2. Let's just double check it again. That's 13. So now we can just continue on our pattern. So this will be 15, 17, 19, 21. Okay, so then this sigma means to sum it up. So we add up this list. So now you could use your summation formulas that we've learned in the past, but this is such a short list, so let's just add it up on our own. So 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19 plus 21, and I come up with 112. So D is our correct answer off of this problem. Okay, that's the end of lesson 11-2. You can write down your questions and your summary.